Welcome students. Circular motion part 3. MCQs number 37. A body rotates with a constant angular momentum of 30 joules into second for 2 seconds. Okay. The torque acting on the body will be. Now we know that torque is equal to final angular momentum minus initial angular momentum divided by time. Okay. Now here the angular momentum is constant. So 30 minus 30 divided by time is equal to 0 divided by 20. So it will give 0 torque. Okay, the answer is 0 torque, 0 Newton meter. Next one. The gravitational force between two unit masses separated by a unit distance is. Now look at here. We know that gravitational force is equal to Gmm divided by r square. Okay. Now it's a unit masses, which mean 1 multiplied by 1. And a unit distance mean 1 radius is 1. Okay, distance is 1. So 1 multiplied 1 is equal to 1 and 1 ones are 1. So only Fg is equal to G. Okay, gravitational force is equal to gravitational constant. We know that gravitational constant is equal to 6.67 multiplied 10 power minus 11 Newton. So let's convert this into dynes. Okay, we know that 1 Newton is equal to 10 power 5 dynes. Okay, now gravitational force is equal to 6.67 multiply 10 power minus 11 multiply 10 power 5 times. Okay. Now when we subtract these two, then the answer will be minus 6. So the gravitational force is 6.67 multiply 10 power minus 6 times. Okay. The answer is this one. Now next one. The gravitational force between two masses is F. If the separation between the masses is half, then the gravitational force become. Now look. When the radius is r, okay, then what is the gravitational force? Gmm divided by r square. But when the separation is halved, okay, when the separation is r by 2, then look, it will be like this, okay, r by 2 square. Now, taking square, we will get r square divided by 4, okay. Now bring this 4 here, okay. Now, 4 gm square divided by r, we know that gm square divided by r square is equal to this one, original gravitational force. Put Fg new gravitational force will be equal to 4 times of the original gravitational force. Okay, when we halve the separation, then the new gravitational force will be equal to 4 times of the original force. An object weighing 80 Newton on Earth's surface will weigh 20 Newton at how much distance from the center of the Earth? So here the options are given that look at the surface of the Earth. It will be weight 80 Newton, but at how much distance it will be 20 Newton. So here we know that the weight, like F force, we can also write it as weight, is inversely proportional to R. Okay, this one. Here we know that 80 Newton is on the surface of the Earth. So on the surface of the Earth it will be like this. Okay, R square. On the surface of the Earth for R square it will be 80 Newton. Then 20 Newton will be 1 over x square because we don't know its value. So just do the cross multiplication here. When we do cross multiplication, what we will have? 80 Newton multiply 1 over x square and 20 Newton multiply by 1 over r square. Now bring this 20 Newton in the division place here. Okay, here it is in multiplication, so bring it here in the division place. Now and bring this x square here above the r. Okay, here it is in division form, so bring it in multiplication. Okay, now it will be like this. Okay, 20 is here and x will be there in multiplication. Okay, now when we do division, like it will cross this one and this, so it will be 4. Okay, x square divided by r square is equal to 4. Now we have to find the value of x. Now bring this r square here. Okay, like this. Okay, now take under root here. When we take under root on both sides, this will cancel this one and we will get here x is equal to 2r. So the answer is x is equal to 2r. Okay, look at here. You have to do this process for finding the unknown distance. Okay, the time period for geostationary satellite is, so it is in your book that time period is 24 hours. Okay, the time period for geostationary satellite is 24 hours. The minimum number of satellites that can cover the whole face of the Earth is. Then the minimum numbers are 3. Okay, 3 satellites can cover the whole face when they are placed at the angle of 120 degree. Let's suppose it's Earth, and when the satellites are placed at the angle of 120 degree, then it will cover the whole face of the Earth. Okay, like this. Next one, the orbital speed v of the satellite is related to its orbital radius by relation. So we know that V0 is equal to GME divided by R. Okay, so the relationship between orbital speed is inversely R. Okay, it will be like this. Orbital speed and the radius relationship will be inverse under root radius. Okay. Next one, a spring balance reads 80 Newton body as 160 Newton. Okay, now look, the real weight is 80 Newton, but the spring balance is reading it as 160 Newton, means it's apparent weight and this one is real weight. Now, what is the next? If the mass of a body is 10 kg, then the magnitude of acceleration. Now, we have to find the magnitude of acceleration, okay? Now, keep one thing in your mind, that when the apparent weight increases, when the apparent weight is greater than the real weight, look, what is apparent weight? It's a tension, okay? It's tension. When tension is greater than real weight, apparent weight is greater than real weight, then what does it mean? It means that the body is accelerating in upward direction. Okay, the body is accelerating in upward direction. It's a body and it is accelerating in upward direction. Now, another thing is that when the body is accelerating in upward direction, it means that the net force will be equal to tension minus weight. Okay, the net force, when tension is greater, then at that case the net force will be tension minus weight. Look here, the apparent weight is tension. Okay, so the tension is greater than weight here, so it means that the body is moving in upward direction. And another thing is that T is greater here. No, so what we have to do, we have to take this as positive. Okay, and the weight is smaller, then we have to subtract weight from the tension. Okay, here apparent weight is 160 Newton minus real weight 80 Newton, and MA is equal to 80 Newton. Now bring this mass in the division. Okay, now put mass 10. Okay, 10 kg. So you will get the acceleration of 8 meter per second. Okay, you will get the acceleration of 8 meter per second. Keep this thing in your mind, that when apparent weight is greater than the weight, the real weight, then we have to subtract the real weight from apparent weight. Okay, the next one, a 100 kg mass attached to the spring balance accelerate upward with 10 meter per second square. The spring balance read the weight equal to. Now what we have to find here, we have to find the tension in the spring or the apparent weight. Okay, tension or apparent weight. Look, when a body is moving upward, it means that the tension is greater than weight. Okay, keep this in your mind. When a body is moving upward, then the tension will be greater than weight in that case. Okay, now the net force will be tension minus weight, and we can also write the tension as net force plus weight. Okay, now we have to find the tension. Now look at here, force is equal to Ma plus W, weight is equal to mg. Now put mass is 100, acceleration is 10, and here mass is 100 and the gravitational acceleration is 9.8. So you will get 1000 here and 980 here. When we add this one, you will get the tension is 1980 Newton. Okay, so when tension is greater than weight, you have to subtract here. Okay, the net force will be subtraction, tension minus weight. 2 astronauts in a satellite orbiting around the Earth in a circular orbit must have. Now here are the options, that they must have the same apparent weight. Okay, they must have the same apparent weight. How? When the satellite is orbiting around the Earth, it means that its motion is free fall. When the motion is free fall, it means that the apparent weight will be equal to 0. Okay, apparent weight will be equal to 0 Newton. So it means that both of them will have apparent weight same, 0. Okay, both of them will have 0 apparent weight, which is same for them. Okay, now the next option is here, same masses. No, the masses cannot be same. Okay, and it can't be changed. Same real weight. No, the real weight also cannot be same for both of them. Okay, now the option is option B, same apparent weight, because the satellite is free fall motion, and in case of free fall, the apparent weight is equal to 0 Newton, which means that both of them will have 0 apparent weight, which is same. Okay, next, a monkey is accelerating down a string whose breaking strength is 2/3, okay? Accelerating down whose breaking strength is 2/3 of its weight. The minimum acceleration of the monkey should be. Now keep this in your mind that when a body is moving down, it means that weight is greater than tension, okay? When a body is moving down, it means that weight is greater than tension. Now what you have to do, you have to just subtract the tension from weight, okay? Because tension is smaller, so you have to subtract tension from weight. Now we have to find the minimum acceleration of the monkey. First, we should know that what is the breaking strength of the string. Breaking strength means that the minimum tension in the body, in the string, the minimum tension in the string above which the string can be broken, okay? The minimum tension in the string above which the string can be broken, okay? So to avoid the breaking strength, to avoid the breaking, tension cannot be more than 2/3 mg of the monkey weight. Look, a string whose breaking strength is 2/3 of his weight. So the tension cannot be more than 2/3 of the monkey weight. Now here F net is equal to ma and weight is equal to mg minus tension is 2/3 of the mg, okay? Mass of the 2/3 of the weight of the monkey, okay? Now just cancel this one with this, okay? So acceleration is equal to g minus 2/3 of the gravitational acceleration. Now take LCM. So by taking LCM you will get 3g minus 2g divided by 3. So 1 over 3g. The answer acceleration of the monkey will be 1 over 3g. The breaking strength here means the tension, okay? The minimum tension. The weight of a pilot during diving down with acceleration of 32 feet per second square, okay? Now the acceleration is equal to g, okay? When the acceleration is equal to g, it means that the weight, apparent weight will be 0, okay? So the answer is 0. Next one. A pilot on an airplane feel negative weight if he accelerates the airplane with. So the cases are given here that in which case the pilot will feel negative weight. Let's find this. So here in the options, first we have to find the upward and then for downward, okay? Look, A and D is for upward and B and C is for downward. Now in which case the pilot will feel negative weight. Look, for upward we use F net is equal to tension minus weight, because in upward motion tension is greater than weight, so we write the expression like this, okay? Now the tension is equal to F plus W. What is tension? It's an apparent weight, okay? So ma plus mg. So we can write it like m acceleration plus g, okay? Here is the tension for upward direction, okay? Now look at the option A. When A is equal to g upward, okay? Now put here A is equal to g. So you will get T apparent weight is equal to m to g. Now when we multiply these terms, then we can say that the value will be positive, because the value of g is positive, the mass is always positive. So when we multiply these terms, the apparent weight will get positive. We will get positive apparent weight. Now look at the option D for upward. A is greater than g. Now put here. Now look at here. Option D. When A is greater than g. Now put in this equation is A plus g. Look. A is greater than g. Now, when we take here like t is equal to m, A is equal to 11, like 11 is greater than 10, okay, or 9.8 plus 9.8. So, we can say that we will get positive apparent weight, okay, the tension will be positive, because 11 is positive, 9.8 is positive, and when we multiply it with the mass is always positive, then we will get apparent weight is positive, okay? So it means that option A is cross and option D is wrong. Now let's check the other two options. Here for downward, we know that weight is greater than tension, okay, for downward motion. Now just bring this weight here on this side, okay? Now you will get minus tension is equal to F net minus weight. So what you have to do is take minus as common. Then you will get minus net force and plus weight, okay? Now cancel these two. Cancel these two minus. So the answer will be tension is equal to minus F net plus W, okay? This will be the answer. Now bring this W here and F net here. So the expression will be like this, okay? Now for downward motion, we write it like tension is equal to weight minus net force, okay? Now, if you know this expression, so don't need to do this one, okay? Don't need to write this one. Directly write like this, okay? Like exchange the places of T and F naught, then you will get this one expression, okay? Now, weight is equal to mg minus net force is equal to ma, okay? Take m as common, so g minus a. Now, look at the option B. Option B says that a is smaller than g. Now, take a is smaller than g. Now, let's suppose T is equal to m, g is 9.8, and I take it as 7. So, I will get m, and this subtraction will give 2.8, okay? 2.8. Now, when I multiply it with the mass m, so I will get positive apparent weight, okay? So, the answer will come positive, not negative. So, it means that option B is also wrong. Now, the next one, check the option C. Option C says that acceleration is greater than g. Now, look at here. T is equal to mg minus a. It's the expression, okay? This one. Now, if I take g is equal to 10 and acceleration is greater than g, so I will take 11 meter per second. Then its subtraction will give minus 1 meter per second. And when I multiply it with mass, then I will get negative result, okay? So, in this case, the tension will be negative, okay? So, it means that option C is correct here, okay? Now, listen. Don't need to do all these calculation, okay? It was just for your understanding, okay? Don't need to do this. Just memorize this one, that when acceleration is greater than g in downward direction, then negative weight will be filled, okay? Just memorize this, okay? This statement, memorize this. Then you will get directly answer as C. When acceleration is greater than gravity, then the pilot will feel negative weight, okay? Just memorize this. Don't need to do this calculation, okay? You have only 45 seconds there in the test. Now, this will take much longer time, okay? It was just for your understanding, okay? I was just giving you the concept that why he feel negative weight. Now, the next one. An object in a satellite orbiting around the Earth is weightless because it's a free fall motion, okay? In case of free fall motion, it will become weightless. The object will become weightless. So it was the last question, last MCQ, okay? If you like the video, then share it with your friends. And if you don't get any MCQ, then write a comment, okay? Then I will answer it, okay? Now, and subscribe my channel. Allah Hafiz.